Welcome to another month where we're going to explore building forensics so that you can become a master of what you are doing. So this month was a really exciting month. There were a lot of really cool jobs that I had. However, I rewrote this entire webinar yesterday, because I had a job yesterday that was just fascinating. So this is a picture of me doing something weird, and I'm about to show you a bunch of other weird things that I saw out in the field. It was a super cool job, so I'm really excited to show it to you. Now, this is the picture that won this month. These were pictures that were sent to me by one of my clients after I went to their house and found that they had massive air leakage into their attic, even though they had gotten their attic stuffed full of insulation. He realized that this is a problem. He needs to stop the air leakage. So what he did was rigged up this very interesting and very creative panel that was held up by this window washing pole with Tupperware that was caulked at the top, basically with this rope caulk. So that was his solution to just stop the hot, moist air from getting up into the attic, and vice versa, until they could actually get it done professionally. So I thought that was super, super cool, and I just wanted to share that with you. Now, this month, we're talking about what clients want, and obviously, I cannot tell you everything in 30 minutes. However, I do tons and tons of content creation, so you can see videos, you can listen to the podcast, which is called the Building Performance Podcast, you can read my book. You can read all of my book on the website. You can work with my software, the software that I use for my own clients. You can get certified, you can consult with me, you can coach with me, and you can attend the Fall Fast Track. And the Fall Fast Track is open for registration right now, so you should feel free to check that out as well. Now, this is what we're talking about. What do clients want? I was reminded of this month because we get these ideas in our heads like, oh, my job is to help my clients become more sustainable, or to be more energy efficient, or to make sure that their water heater isn't spilling, or that their furnace is creating not very much carbon monoxide even though it's sealed combustion. All these things, and if you're a homeowner listening to me say that, I'm not going to get super technical. I'm going to try and keep this as easy to understand as possible, but we need to remember that our clients want what they want, and our job is to give them what they want. They have pain, we solve the pain. I got a phone call this month from a friend of mine, and the phone call went something like this. Hey, how's it going, Corbett? I have a question for you. I had asbestos, and it was removed, and the remediation company used some stinky paint to seal up where it used to be, and they covered up some of the tiles that they actually left in place. But it still smells, and this happened 3 months ago. So please, can you tell me what I can do? Is there some kind of a paint I can put on it, or a product that I can clean it with to make it stop? My always, right, because I'm thinking about like, oh, this should have been done quality-wise, is that I would like to advise him that something was done wrong. That's not right, that's going on. You shouldn't be able to smell it 3 months after they've left. So I say I would be happy to reach out to that company that did the work and very vaguely and lightly threaten them with, hey, listen, you did something wrong, you need to go back and fix it. He was not interested in that at all. What he wanted from me, and he kept saying, well, I understand that's your position, but I just want to make it stop. That's all. He did not want to sue anybody. He didn't care that it was done right or wrong the first time. He just wanted it to go away now. And that was a really good reminder for me, because I get up on my high horse and I'm like, oh, everybody needs to do it right, or they need to be rewarded for doing right, or they do it wrong and they need to be found out and punished in whatever, whether that's they have to do a callback and do it right the second time or whatever. But that's in my brain, and it's not in my client's brain. So the next thing in line is they don't want any mold. This was a job that I had last month where I was consulting on a house that was being built. We have a basement that is underground, and it holds the basketball court, of course. These foundation walls are 11 feet deep, and we've had a pretty wet summer here in Chicago. So what we do is go in and test the moisture content of the wood framing members. I tested the wood that's up against the wall that has an exterior layer of waterproofing that is just up against the fiberglass, which is up against the concrete, which, like I said, is protected by an exterior layer of waterproofing. I also test the wood that's located on the wall with the interior layer of waterproofing, which they weren't able to put on the outside because of this and that and blah, 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 the alley encroaching, etc. It's not necessarily always the way that it gets done. I hadn't seen this before, but Anyway, what we were able to find is that these two contents were about the same. There's no way that water could get in through that dimple board in the middle and make the wood wet. So what we were able to ascertain is that, that the wood is wet because of stuff that's going on inside the house, not the rainwater coming in from outside. Also, these foundation walls were all about 60 degrees, and what we were able to find is that the dew point of both the inside and the outside air was about 47 degrees. So we're not worried about condensation. We're not worried about water coming in from outside. This is all construction, wetness, drying out. The air conditioning just came on yesterday. This is a big building that I was in charge of testing and balancing for verification as an independent third party. So I come in behind the installer and I test their work just to make sure that all the airflows are correct. I used a TSI AccuBalance 8371. You don't have to know what that is. It's a flow hood. But basically, my job is to know how accurate that tool is and how exactly to use it. The tool accuracy is plus or minus 5%. So let's say that I test 1,000 CFM. That would be plus or minus 50, and then plus or minus 5 CFM. So it's plus or minus 55 CFM. So it could be actually as high as 1055 and as low as 945. But this tool that I used, I checked the calibration date on it because I rent my flow hood. I don't own it. And this hadn't been calibrated in a couple years. So I did the adjustment for the plus or minus 5%, as you can see there. This spreadsheet, by the way, took me like 15 minutes to set up, and it's because I use apt reports, which is an Excel-based reporting tool, and it just makes you really good at Excel. So I am not an Excel genius. I'm not an Excel trainer. You can do this too. On the very far right, I adjusted it to assume that it's possible that this tool has slipped 15% out of true, not just 5%. That's triple the amount of error. Now, here's the thing. It wouldn't flip-flop around 15% one way or the other way. It would have slid south or north of where actual airflow is by 15%. And what I found when I did that is I still have test airflows that are outside the range of 10% error that is acceptable. So our target was 110% and as low as 90%. That's the range that we're looking for. 100% on the dot would be fantastic, and you see that there's one that's 101. That's fantastic. But in general, there are things that are still outside the range, even if my tool is inaccurate, and that is how you can start to use tools that even though you know that they are a little inaccurate, you can work with that inaccuracy and really start to find this stuff. Now, this is my special job that I rewrote this entire webinar last night because of. Got a call last week from a gentleman who was referred to me by an HVAC company here in town that's really a good HVAC company. They have a problem with their smelling in the house. So here's what happens. In the morning, they come downstairs and they can smell the chimney. They open up the back door to take the dog out, and all of a sudden, the smell goes away. The chimney was lined. It was actually inspected. They broke out all of the clay stuff. This was unrelated, by the way. And they lined it with a brand new liner, and they sealed it up and insulated it and blah, blah, blah 2 years ago. I'm assuming that this all worked perfectly well because I'm not a chimney expert. And it's cleaned twice a year because in the wintertime, they use it every single day. This guy would run the fireplace all the time if he possibly could. He loves the fireplace. And that is good. We want people to love things. And I, as a building diagnostics expert, want people to love things that cause problems in homes. And let's be perfectly clear. A wood fireplace causes problems in homes nowadays. So I am not in the business of trying to get people to not use wood fireplaces. I'm in the business of trying to give people what they want and have there be no side effects. And that is your business too if you do this kind of testing. So don't fool yourself into thinking that you're going to talk everybody out of having a wood fireplace. Now, this is how they used to have this work until 2 months ago when they did this. The window in the basement mechanical room was always open year-round. It's a little tiny window, but 2 months ago they installed these solid window well covers instead of the grates that they used to have where air could flow down into them. So now they've sealed up that window and now they can smell the chimney all the time. Now, if you are a building diagnostics expert, which I hope many of you, even if you use it once a week or once a month, you should think of yourself as an expert. It helps you to gain your confidence, and you need to use it more often, basically. You need to start looking at the symptom. Now, you probably are having some ideas. Now remember that in the very beginning of any interview with a client, you do not open your big mouth and start talking about what it probably is or what the cause is probably. So we're just collecting data at this point. So I'm going to tell you all the data. This is our symptom that is going on. This is how they can tell that something is wrong, is they can smell this fireplace. Now, the fireplace is used all the time, and as you can see right here, it doesn't have a fresh air intake from outside. That's, we're not drawing any conclusions from that. I just wanted to point that out. Now, the air quality problems that we deal with are always, if you listen to the Building Science Corporation, made of 4 P's. Of course, there have to be people in the house who care about it. There has to be a pollutant. We know what that is. That's the chimney air that's coming into the house. There has to be a pathway for the pollutant to come and meet the people. And there has to be a pressure. So we're looking at all 4 of these things. And we know the people. We've interviewed them. They're very nice. We know the pollutant. We now have to investigate these pathways and pressures. Now, what you can see here in this Google Maps screenshot is these black dots on the roof. And you can see one of them right there. That, my friends, is, and you may already know the answer to this, an attic fan. And it's actually a special kind of attic fan. It's a solar-powered attic fan. Green, right? Everybody loves green. Everybody loves solar power. Super sexy. Awesome. We have 3 of these things on 3 different attic spaces. Now, here's the way that all of this is going to play out. The pathways are both in and out. We know that there are exhaust fans in this house, and you can see them here on the right. And we know that there are pathways between the house and things outside of it. As you can see here, we've got top plate leakage on the left. That's leakage from the attic down behind the drywall into the wall cavity. And if you don't know that that's happening in your houses, you need to know that, because that is a big, big deal. And you can see a really beautiful picture of it right there. Any place where you've got a light switch or a fixture in a wall on the top floor, the conduit that is serving that, the electricity, is going up and out into the attic. And there's a hole around that wire, and that is what you are looking at in the middle picture. By the way, in the right here, you can see these 2 silver exhaust terminals on the outside of the house. There are 8 exhaust fans in this house. Those 2 are the 9th and 10th, and those aren't connected to anything. And I knew this because I counted all the exhaust fans on the inside, counted all the terminals on the outside, turned on all the exhaust fans on the inside, walked around the house and looked at all of them working, and these 2 were not blowing anything. I used a little smoke pen to be able to tell that. So now we know the pathways. We know the pathways in and out of the house, as well as the chimney, obviously, is the pathway in for all that air over the nighttime. Now we need to look at the pressures. Now, these solar attic fans are kind of a big deal. This is a SketchUp model of the house. I make one of these for every one of my clients just so that they can understand how their house is built, because a lot of people don't understand how they've got mystery cavities in their houses and where the chimney goes and all that stuff. This is all really, really useful. So if you can learn how to use this, and by the way, I have a 30-minute video on my YouTube channel on how to learn SketchUp in 30 quick minutes. I was taught by my former partner, John Bergman. So you can see all of these exhaust terminals that I labeled here. Those all added up at the same time only depressurize the house by 5 pascals. That is not a lot. That indicates a couple things to me. That indicates a very leaky house, and it indicates that those fans actually don't do a lot. When I then go around and measure every single one of those exhaust fans to do my job thoroughly, I actually find that they move a lot of air. So now I think that the house is really way leaky. Now, those 3 hexagons that you can see in the roof indicate those 3 different attic spaces and the 3 different depressurizations that we're going to have. Here's a picture of one of them on the left. This is in an attic that is 120 degrees, and all attics in my neck of the woods are 120 degrees. They can get up to 130. It's not a super pleasant place to work. That's why you pay attic air sealers well. So we've got the solar attic fans on the left, and the intakes that were just installed by my HVAC colleague who referred me to this job. Now, a couple things. Those intakes that you can see right here are very low to the ground. So guess what's not going to work when it starts snowing in December? Those are not going to be bringing in any air in December. So that's one thing that I just want to kind of indicate to my client. Also, they are going into the return side of the plenums, of the 2 furnaces. And if you don't know what that is, you can ask in the question pane. So the solar attic fans are each depressurizing the attics by 4 pascals. Every single attic was 4 pascals depressurized with reference to outdoors. And this does take a fair amount of hoses to be able to do, and it does take time. I spent 5 hours at these people's house testing all this stuff. So now I know that these fans are actually working, they are blowing air, and they are depressurizing these attics. These intake ducts are 4 inches. A lot of intake ducts will be 6 inches. I've seen 8, 10, 12 inch, pretty huge. You do not guess. I'll just say that. When you are designing this stuff, there are absolutely calculations that you can use to design in exactly how much air is going to go through these things. So we want to know, here's this 4-inch duct, what's going on in there? Because part of my job is to deal with the pressures in the house, and I want to know what these are doing to my pressure in my house. So I drill a hole, and I'm going to test it. Excuse me, I use a mini vane anemometer. It's a Testo brand. You can see me use it in a video on my YouTube channel on airflow. Each of these is blowing about 50 CFM. That means 100 total. But they only work when the air handler of the furnaces are running. And that was actually a concern of the HVAC professional, and that's why he turned their thermostats to fan on position, which means that the blowers run continuously nonstop. This is a little bit of using kind of a, you know, in caveman days when the cavemen apparently used to hit girls over the head and drag them back to their cave. Totally unnecessary, way over the top. It's the same thing here. Using 2 furnaces running 24 hours a day to solve a problem with depressurization is a little bit overkill. There is a much more elegant way to do this. So now it keeps on adding to this data that I'm getting, right? So we've got this picture of this house. Now, this door on the left is where you are going to put the blower door because it is close to the fireplace. I'm going to use the blower door for something other than just a depressurization test. So what we're going to do is pressurize the house so that we can get it to turn over the depressurization mark, and we're going to get it to 1 pascal of pressure. That, for those of you who don't know what that is about the weight of a Post-it note. It's hardly anything at all. You wouldn't probably be able to feel it without being totally wet and standing in a doorway. To get that, we had to blow 230 CFM through my blower door. And to get to 2 pascals, we had to blow 350. So guess what those little fresh air intakes in the basement that are 4-inch ducts are actually doing? Not much, is the answer. So when we run the blower door test, remember I was expecting a very leaky house. The target that I always look for in my local area, because we abandoned the NACH thing, which was from 1989, and if you don't know what that is, don't worry about it because it doesn't exist anymore. We shoot for 5 air changes per hour at 50. That's the Illinois state code for air tightness. My target CFM reading on the blower door then is 3903 for this house. I actually got 3670, as you can see here on my left, and that's a screenshot off of my phone because I use my phone to rest my blower door. Super, super helpful to have the Wi-Fi capability now. I also pressurize every house that I go into. I do both depressurize and pressurize because, number one, that's how it's written in the testing guidelines, and number 2, it's very useful to know that stuff. Now, the pressurization number is way higher than the depressurization number. It's about 600 higher, as you can see. That's about 15%. And that is because, like I told you, there are 8 exhaust fans in this house, and each one of those has a backdraft damper that will close against air trying to come in. But they will all blow wide open when you are pushing air out of them, right? So that's normal, and you will see that. There are a couple other reasons for that, but we won't get into it. So actually, this house would pass current code, and current code is only 5. It's not 5.0, so we could go up to 5.49 and still pass the state code. So this is something that's good for my clients to know when they resell the house. It actually meets the state energy code. So here is my idea. Now that I've got all this raw data about what's going on in this house, the attic fans are sucking on the top floor, right? Because they're sucking on the attic, and the attic is sucking on the top floor because we know we have top plate leakage, which I took a picture of with my infrared camera and also measured with a pressure pan, and did zonal pressure testing on the attic. Okay, so there's that. That's due to the fans. The top floor is also at the same time, in the summertime, sucking on the attics because of reverse stack effect, because we're cooling air down in the house, it's sinking, it's creating high pressure in the bottom of the house and a low pressure in the top. That means that the top floor is sucking on the ceiling, which is sucking on the attic. Those are happening in about equal measure, I believe. It's about 4 pascals, like I told you, in the attics, depressurized, and due to the delta T today, it was about 1.5 pascals per floor, so that's 2 floors. That's about 3, so they're kind of sucking on each other in equal measure. Now, when the sun goes down, the attic fans turn off because the attics lose their temperature, and it's set to a thermostat or to when the sun is up, right, because they're solar. So the attic air now comes down into the house because there is no air conditioning. The delta T is low enough. At sunrise, the attic fans then turn on again, but there is still no delta T for the stack effect to take effect, right? So that then is resulting in our clients going downstairs, having breathed attic air all night long, not chimney air, and they get downstairs and now they can smell the chimney air. Also, they're used to it. When I walked into the house at 10 o'clock in the morning, I could smell it. I asked my client if he could smell it without telling him I could, and he said, no, it's not here now. So they are obviously used to the smell of the chimney, and it's just something that happens to people. Okay, so except when they've been breathing attic air all night long. So now that we've gotten all crazy heady and theoretical, and to be perfectly blunt with my client, that was theory, right? It was hypothesis, not based on testing or data logging. So here's what we're going to do. We're going to give them control because that's what they're asking for. They are not asking for some new furnace or blah, blah, blah. I could tell them to just open their window again and go back to the way things were, but that's not what they want. They want to move forward, not backward. So I'm going to help them choose the practical solution, the one that will actually solve their problem, which is sometimes going to be not the best idea ever, but it's better than all the other ideas. So the problem here is that this is a very subtle problem, right? We're talking about 4 pascals of depressurization, 3 attic exhaust fans, all these different little things that are adding up to a big problem. And this is what is going to happen in every neighborhood, in every city in the country by 2017, because we are going to be enforcing the 2009 International Energy Conservation Code. Houses will have subtler problems, and you will have to solve them with diagnostics. So if you're in an area where you're bemoaning the fact that people don't do, contractors aren't asking for these tests, etc., it's okay. Just wait, because it will come to a head, and you will have people starting to get pissed off, especially when we go on TV next year and explain how this works on network television, so that people know that they're getting cheated if they don't get testing. So the subtle solution did not work. Now, this thing over here on the left is our fireplace, like I showed you, but that right there is a draft inducer at the top of the chimney. It's called a chimney top fan, okay? And it sucks on the chimney. That has been disabled. In 2007, when the former 40-year homeowner moved out, they had disabled it, and the new homeowner moved in. Now, the fact that that's there is very interesting. It's connected to something that looks like this. That is going to be very, very useful for us, because that is one of the first steps that we can use to get this thing done. So we are going to reactivate the chimney top draft inducer. Let me be perfectly clear. This is not energy efficient. What I'm going to recommend to my client is when they burn a fire at night and then they go to bed and they let the fire burn itself out and the flue is wide open, they're going to leave that exhaust fan running, and it is going to be sucking air from the house up the chimney, and you're going to be wasting lots of conditioned air. That is not energy efficient. That is not a concern for my client. They want to solve their smell problem. Later on, they might want to be more energy efficient, and then we can help them with that down the road. Secondly, all the attic fans have to be deactivated, except for the solar ones. We want the attics not to suck on the house. Now, I'm going to get into the solar thing in a second, but the attic fans are completely and totally unnecessary. Always, always. You never install attic fans to solve comfort problems on the top floor of the house or mold problems. And if you, please rewind this and listen to me say that again if you need it. But the attic is full of hot, moist air in the summertime, which is the same as outside. And the attic is supposed to be the same as outside in every way except no animals, no precipitation, and no wind. In the wintertime, the attic is full of hot, moist air too, and that's because it's getting air from the house. The solution to that problem is not to install a fan that sucks on the attic. The solution to that problem is to air seal the attic floor so that no moisture gets up there in the first place. And that is the only answer, period. And you are welcome to ask questions about that. I am happy to take arguments about that. I think that you guys are all on the same page with me. Now, these solar things, right? Everybody loves sexy solar. They're so cool. They're black. They run all by themselves. They don't cost any money. These things suck. And they pissed me off royally because they have no off switch. We called the installation company and said, hey, how do we just turn these things off so they stop running? And they said, well, you can't. When the sun comes up, they run. When the sun goes down, they stop. So we have to actually ditch these things. We have to rip them out of the house and then patch up the roof. We can't just turn them off. That is the mark of a piece of crap product. So please, if you're listening to this and you manufacture or install solar attic fans, do not install anything that doesn't have an on-off switch, because that is going to be terrible for you. I'm going to go around town bashing these solar attic fans forever. And around the country, by the way, because that sucks. That is not right. Thirdly, we got to seal that attic floor, because that is going to solve problems that will develop down the road. So now we've solved the pressure problem, we've solved the pathway problem. They're not going to solve the pathway problem, by the way, because they love their fireplace and their chimney. So essentially, we have taken care of the fact that air is going to be leaving in the wintertime, not right now, and solve the pressure problem with that chimney top draft inducer. So if you want to know how to analyze houses like this and really prove that you are the badass in your local area, you need to come to this. It's 6 weeks with me, and I give you all of everything that you need to do to become just like me in your local area. My goal is to have one ninja, one black belt in every single market in the United States, so that everybody can be doing testing still. But these very complicated jobs, you call the ninja. And that's why we need them all over the place. So you need to go to homeperformance.training right now and check this out if you haven't already. You can take a 10-minute tour of the course and learn about it. You don't have to travel at all. You don't have to get a hotel room. You incorporate it while we are working on the stuff over 6 weeks. So you're actually incorporating the stuff and learning to use it, not just put it in your head. Thanks very much for watching. I will take questions now. And I hope, by the way, that you tune in next month as well.